Okay, so for this video, we are going to discuss another method to locate the approximate root. All right. So in the previous video, we tried to locate the root by using the graphical method. So for this part, we are going to discuss the sign change method. All right. Okay, so for the sign change method now, maybe before we start to apply the methods, we maybe can have a look for the equation first. Let's say when you're having the equation fx equals to 0. All right, so before you want to get the value of x, you can sketch the graph for fx first. So as an example, like this is the graph for fx, let's say. So after I sketch out the fx, and when I let fx equals to 0, that means I want to find out all the roots here. Okay, when you let fx equals to 0, you are trying to find out all the roots, or maybe the values of x. Okay, so all these are the values of x. You should be able to see it, right? Okay, so there's one thing very interesting that if you can observe in the graph here, this is root number 1. All right, so you can see that this is root number 2. Okay, x2. And then this is root number 3, let's say. Oh, sorry, I should write it as R1, R2, and R3. Because in the graph, they have some other things. Okay, R1, R2, and R3 are root number 1, root number 2, and root number 3. Okay, so there's something very interesting that you can observe is, okay, let's say for root number 1, if you can observe, when you substitute any value before the root number 1, you'll get this part of the graph which is negative, right? Below the x-axis, therefore this part of the graph is negative. If you try to substitute any value after the root number 1, okay, so you will see that no matter what value you substitute, as long as it is larger than root number 1 but smaller than root number 2, you will see that this part of the graph is above the x-axis, which means you will always get the positive value. So you can see that before root number 1, when you substitute a value before root number 1, the equation, the value for fx is negative. But if you substitute any value of x after root number 1 into fx, then you will see that your f root 1 is equals to positive value. From the graph, you can see it is above the graph. All right, so the value before the root and after the root are different signs. So therefore, we call it as sign change. Okay, we can observe it another one on root number 2. If you substitute any value before root number 2, okay, but of course, it must be larger than root number 1. Any value larger than root number 1, less than root number 2, if you substitute the value in it, from the graph, you can see that you are getting a positive value. Okay, but if you try to substitute one value after the root number 2 into the fx, you will see that the value that you get is negative. So again, if you refer to root number 2, before root number 2, substitute the value before root number 2, you get positive sign. After root number 2, you get negative sign. So again, before and after the root, you can see the sign change again. So the same thing applies for root number 3. So because of this special characteristic, they realize that, oh, okay, as long as when I have a root in the equation, although I don't know the root, okay, but if I can substitute any value, and once I get the sign change, that means I get the root between them. So as an example, because I don't know what is the root, for this kind of question, we actually cannot find out the root, correct or not? Okay, so as an example, if let's say I don't know what is my root number 1, this value I don't know, okay, but maybe I substitute, okay, let's say this value is 0, okay, so 0, I substitute the value here, then I'll get a negative value, correct or not? Okay, then maybe I choose another value, let's say this is 1, so I substitute value 1, then I get a positive value, okay? So from here, what can you observe? You will see that between 0 until 1, I got a sign change, right? Because I got a sign change, which means the root lies between 0 until 1. between 0 and 1. The root is between 0 and 1, just I don't know what is the exact value only. What is the most the answer? Just that I roughly know that the root is between 0 until 1, because when I substitute 0 and when I substitute 1, I see a sign change in the function. Alright, so this is the concept for the sign change method lah. Okay, alright, so you will see here the explanation is each time the curve crosses the x-axis, the sign of y changes. Therefore, we use sign change rule to locate the roots of an equation. So this is the second method. In the previous video, we locate it by using the graph. Alright, so this one by using the sign change rule. So this is the second method now. So comparatively, for these two methods, right, the graphical method, the range, the interval usually is larger because you only sketch a graph to estimate it. Alright, so for sign change method, the range that you get where the root is in is smaller. Alright, so that means to me this method is can give you a smaller range to know where your root is located. Okay, alright, but no matter how, both methods have to learn, because usually in one complete question they will ask for all this. First one is graphical, they will ask you to sketch graph. The second method is sign change, and then after that the next method is to find out the value, okay, the approximate root by using the iteration method. Alright, so usually it comes in a set. So I have to learn all the different methods here. Okay, so now let us continue with the sign change rule. Alright. So here they actually tells you that if let's say there's one root, okay, of this equation lies between x1 and x2, and when you substitute x1 into the function and x2 into the function, then you will get the opposite sign. Okay, so this is a summary for the method that we use. Okay, but of course in exam we are not going to write out all this, right? Okay, so how can we actually set up or write out the steps for the exam style question? Okay, so again, example 3. Okay, so for example 3, they want you to verify by calculation. So if they want you to sketch a graph, they will ask you to sketch graph. And then if they want you to use calculation or sign change method, usually they will ask you to use the calculation. They won't clearly write out the sign change method, but they will ask you to verify by calculation that you have only one root between two numbers, 0.5 and also 0.8. Okay, so what they want you to verify, you have only one root for this equation in the interval. So this is the way that they ask question. Okay, all right, so how can we apply the sign change method? Okay, so first of all, what you need to do is that you have to make sure that you move for this equation, you move everything to one side. That means either you move all the things to left hand side or all the things to right hand side. It doesn't matter, as long as every expression to one side, all the expression to one side. Okay, so like for example, you can write fx equals to cotangent x minus 1 minus x squared. So this is the first step. You must have the equation in terms of function. All right, okay, by moving everything to one side. Okay, all right. Then after that, in this question, they are asking for two. They said that they want you to verify the root is between these two values. So very simple. You substitute 0.5 into your function, and then by pressing calculator, you can see what's the value that you get, and you write it out. So usually I will write out until 3 significant figure. So for this example, I will get, when I substitute 0.5, I'll get 0.580. Okay, so you can try to press calculator and see cotangent 0.5 minus 1 minus 0.5 squared. If you didn't get 0.580, okay, so let's continue. So if let's say when you press the calculator and you cannot get the value for 0.580, that means you need to double check and see whether your calculator is in radian mode or not. All right, so as what I mentioned before, right, besides the trigger chapters, Okay, when you do any question that involve trigo in other topics, then generally everything we calculate it in radian. All right, so this is one of the small reminder for all of you. All right, so if you cannot, when you press the calculator, substitute the value, you cannot get 0.580, please double check and see whether you put your calculator in radian mode or not. Okay, all right, then after that, the next value that you are going to substitute is 0.8. Okay, so for 0.8, again, you just substitute in the value and see what's the value that you get. If you didn't do any careless mistake, you should have 0.669. So very obvious, you should have one positive and one negative value. Definitely you will have it. Okay, if you don't have, that means something wrong with your calculator or something wrong when you press the calculator. All right, so when they want you to prove, you should get one positive and one negative value. Okay, so you can see the sign change here. All right, so for me, I will just make the simple conclusion also before, after I get the sign change method. So usually I will put it as this. So there's a sign change, okay, between f 0.5 and 8, f 0.8. Okay, so there is one root, okay, in between 0.5 and 0.8. So usually I will make a conclusion like this. All right, so according to marking scheme, right, they will actually request students try to write out the conclusion if can, because some marking scheme, they will attach the mark with included the conclusion, some not. So I think the best way is still write it out. Okay, so this is how we use the sign change method to locate the roots. So you can see that it's very simple because in the question itself, generally they will already give you the values here. Unless if they didn't give you these two values, then you have to try and error by yourself until you get the sign change. All right, so that's the worst case. So if let's say usually normally for the question in the exam style, the A-level exam, they will give you these values already one. But I remember that there are some questions, they ask you to do the trial and error method. That means you have to trial one by one, okay, one value from one value until you get a sign change. All right, okay. So usually for this question, they'll give you only 2 marks. The graph one will give you more. Okay, this one usually at most is 2 only. All right, okay, so this is how we apply the sign change method. You can try it for example 4. Okay, so before that, I just want to let you all know, if let's say just now you are moving the cotangent x to one side, which means maybe you have something like, if your fx is 1 plus x squared, then minus cotangent x. All right, so in that case, then the value here, the sign here will be different. So you'll get a negative value for 0.580 and then a positive value for 0.669. So it doesn't matter. As long as you can see a sign change in your calculation, that means you're correct already. Okay, so no need to worry about all this. Right? Okay, so let's continue with example 4. Okay, so for example 4, again, because it is not hard at all, so I think you should try out on your own. Okay, you can pause the video here and then you can try out on your own first and then try and see whether you get the answer correctly or not. If you didn't do any careless mistake, then your answer will look something like this. So for me, I will move the t over. Okay, then minus t. So for f 1.2, okay, I will get 0.0599. And then for f 1.3, I'll get negative 0.0194. All right, so this is the value that you should get, and after that, you make the conclusion here. Okay, all right, so this is the second method for us to locate the root by using the sign change method. Alright, so in the next video, we are going to proceed to the more detailed method, which is the iteration. So the iteration will help us to get the approximate roots until maybe a certain level of accuracy, like maybe 3 decimal places or 4 decimal places. So we'll discuss all this in the next video.